All right, Chapter 8, Review, Part 1. So we are simplifying, we're solving all these rational functions, getting common denominators, all that good stuff. So let's get after it. So number one, we need to first simplify the numbers. So for 24 and 9, the first thing that goes into both those numbers is 3. So if I divide them both by 3, I'm going to have 8 over 3. And then I have 14 x's on top, which these will cancel out. And that'll leave 2 on the bottom. So number one, that's what we get. Undefined value, what can x not be equal to? Well, x cannot be equal to 0, because otherwise we'll get a 0 on the bottom, will be undefined. So on this next problem, when are we going to get a 0 on the bottom? So when is 3x plus 12 going to equal 0? And we solve it, and we get 3x equals negative 12. So it looks like x equals negative 4 would give us an undefined. So we're not allowed to be negative 4. Now let's go through and let's simplify this thing out. It looks like when I want to simplify this, I got to look at all three terms. This one, and this one. And the only thing they all have in common is a 3. So I'm going to just kind of divide everybody by 3. I'm going to get 2x to the third over x plus 4. And now none of those three terms have any more common factors in them, so we're kind of done. The one to the right's traditionally what you normally see, so we're going to factor this. So on top, I'm going to get an x plus 4, x minus 3, and what I'm hoping to have happen is get something to cancel on the bottom. Looks like I'll get that. I'm going to have an x plus 4 times an x plus 1, and the 4's cancel out. And so this right here would just be my final answer. All right, moving on down, multiplying the expressions. Multiply expressions are nice because you do not need a common denominator. So no LCD needed. All right, you just go straight across. One thing that you can do is that you are allowed to cancel on a bow tie, meaning you can cancel up and down, but then you can also cancel kitty corner. Only when you're multiplying. You can't do this with an equal sign in here. So first step, let's factor this. So I'm going to get an x plus 3 and x minus 1 on top of, down there looks like an x minus 2 and an x plus 1. So nothing's canceling yet. But then I'm going to multiply by an x minus 2 over an x plus 3. And now I can get some canceling going on. Got the minus 2, plus 3, and I'm simply left with this expression right here in the middle. Now over here to the right, I know in class some kids had some trouble factoring this one. So just remember, like if I was going to do x squared minus 9, that's just the difference of two squares. X times x gives me my x squared, which just ends up being the square root of this front term. And then I get a 3 and a 3, positive and negative, and that's just the square root of the back term. And the middle term, the x term, canceled out because one's a plus and one's a minus. So if I were to give you something a little more challenging and I was to say, hey, how about 49x squared minus 81? You can still do this the same way. The two front pieces are going to times together to make 49x squared. So that's going to be a 7x and a 7x, which turns out to just be the square root of that guy. And then my back number will be the square root of 81, which is a negative 9 and a positive 9. So I think that was where we had a little bit of issues on this problem. So for this particular one, to get 9x squared, I need a 3x and a 3x. That'll give me 9x squared. And then I have a plus 1 and a minus 1. On the bottom, that's the difference of two squares. That's an x plus 3, x minus 3. And then over here to the side, we're just multiplying by another x plus 3 and a 3x plus 1. So if you didn't get that 3x plus 1 on the top left, you wouldn't have been able to cancel very well. But the 3x plus 1's cancel, the x plus 3's cancel, and I'm simply left with this expression right here in the center. So multiplication's not too bad. Division, remember, on these, you're just going to keep, change, flip. All right, so KCF, keep, change, flip. You know, technically, we are multiplying by the reciprocal. So the first one is not really a, they're monomials. There's no pluses or minuses in there. So I'm just going to go x to the third times y, which is really y to the first, over 4x to the first, y to the fourth. And this is over 8y squared times x to the first. Now you might be like, well, why is he putting x to the first in there, or y to the first in there? Just because I want you to see that when you multiply powers, you add the exponents. So when I go straight across on the top, this is really a 1. So 1 times 8 is 8, x to the third. And then I have y to the first and y to the second. So that's going to give me y to the third. So I'm just multiplying straight across. On the bottom, 4 times 1 is 4. That's going to be x to the first times x to the first, and then a y to the fourth. Now I want to start canceling. 4 goes into both these numbers. It goes into here 2. It goes into here 1. My x's, these two, will wipe out 2 of these, and there'll just be 1 left. And these y's, 3 of those, will cancel out with 4 of those, and there'll just be 1 there. So what I'm left with on the top, I'm left with a 2x to the first. On the bottom, it's just 1y to the first. So that's the cleanest way to kind of write that. All right, over here on the side, I definitely want to do some factoring. So this looks like an x plus 3, x plus 1 on the top. On the bottom, it's going to be an x plus 4, it looks like, times an x minus 2. And now that's the keep. Now I got to change, and then I got to flip. So let's do a little flipperoo action. This can be factored right here. I can pull a 3 out of there. And that's going to hook me up and give me an x plus 1. So that's kind of nice because I see an x plus 1 on top. So let's cancel stuff out. Plus 1, minus 2, minus 2. That's lovely. So on top, I have an x plus 3. Over on bottom, I have a 3 times an x plus 4. You're fine to leave that alone. If you really want to go further, you could simplify it further, and you could distribute and get the 3x plus 12. All right, moving right along. Find the least common multiple for each pair. So we got to find the first thing that both of those can go into. So this one right here, well, that's x plus 3, x minus 3. So I know I have those two factors. Well, then over here, I have an x minus 3 times itself, x minus 3 squared. And whenever the two terms have a common factor and one has a bigger power, you have to use that power. So overall, it's going to be an x plus 3 times x minus 3 squared. So now, if I wanted to, this side could just be times by x plus 3. This side could just be times by an x minus 3, and they would both be able to turn into this. That can accommodate both of those. When I'm looking at the next one, 4 and 16, well, 16 is the least common multiple of those two. I have an x squared and I have an x to the fourth, so you always choose the biggest power because they both can go into that. Y to the third, y to the first, so I'm going to choose the bigger power. Boom. That one's a little easier. All right, moving on down, number 10, add or subtract. This is where we need to start finding an LCD. So we need to find a least common denominator to add the two fractions together. 10 and 11 looks like we have them. So I have 2x over x plus 4 minus 3 over x plus 4. So since they both have a bottom of x plus 4, that's going to stay the same. And on the top, 2x take away 3 is just 2x take away 3. Like, there's really not a lot to do on that one. Same thing over here. They both have an x squared plus 4 on the bottom, so that's not going to change. On top, I have 4 plus x squared plus 8, so the 4 and 8 will combine to an x squared plus 12. All right, now we get into a couple harder ones. The harder ones, these do not have matching denominators. So since one side has an x plus 3, the other side has an x minus 3, I'm going to multiply this side by that x plus 3 over itself. And I'm going to multiply this side by the x minus 3 over itself. And so really I haven't heard anything. You know, I'm still adding two fractions, and all I did was multiply by 1. But I'm now making both of these fractions have the same bottom number. So like over here, my denominator is x minus 3, x plus 3. And on top, 1 times x minus 3 is just x minus 3. Now we need to add to that. Over here on the right, on bottom, I have another x minus 3, x plus 3. And on top, 1 times x plus 3 is x plus 3. So now I have the same denominator, so I'm going to add them up. The denominator is not going to change. But I do need to add the two tops up. So I do need to add this plus this, which is going to give me 2x's. And the plus 3 minus 3 cancels. And we are simply left with that there. All right. Next one. And I think the answer key, I actually worked the bottom out. And I actually just called this bottom x squared minus 9. You could do that or you don't have to do that. It doesn't really matter to me. All right, the next one. I'm going to first factor this because I can't really see what the LCD is until I factor it. And this is going to be an x minus 3, x plus 2. And over here, I just have an x plus 2. So in order to get these to have the same bottom, I only need to multiply this side by the x minus 3. And there's no equal sign, so I can't just multiply both pieces by something because it's not balanced in. So now I got to kind of work this out. So over here on the left, nothing has changed. I just have 1 over x minus 3, x plus 2. Take away, well, over here on top, this is going to be an x squared minus 3x. And then my bottom is the minus 3 plus 2. Now I got to be really careful because when I'm doing subtraction, you know, it's one take away that parentheses. So I really need to distribute a negative 1 through here. So on top, I'm going to have 1 minus x squared minus 3x all over. And I could leave those two separated, or I could multiply those two together. Maybe this time I'll multiply it together. And you'll get something like that. Or if you wanted to just put this stuff down there, you could do that too. A standardized test is probably going to put this in descending order of powers. All right, which would look like that. These are all the same expression, just how do you want to package your answer? All right, moving on down, number 14. I'm subtracting here. I have different bottom numbers. So I'm going to multiply this side by a 3, or not a 3x, that's already what's on that side. I'm going to do this side by a 2x plus 1 over a 2x plus 1. And this side's going to do a 3x minus 1 over 3x minus 1. No harm done, just multiplying by 1. But this is kind of one big old fraction, and then take away another big old fraction. So we're going to handle those separately. So over here on the right, on top, I have a 6x squared minus 2x over, on bottom, I'm just going to leave it like this. And then I have a big fat takeaway. That's kind of code red, like, hey, I'm going to have to distribute something. Over here, when I do this side, I have 14x plus 7. Kind of put that in parentheses because the subtraction is going to be important there. On bottom, I'm just going to keep it the same. And looks like over here, I kind of screwed up. That was a minus. So 3x minus 1, 2x plus 1. And now we need to distribute. So we need to distribute this -1. And on top now I'm going to have 6x squared, subtract 2x, and then after distributing, minus 14x minus 7. All over, I wish I could just copy and paste instead of rewriting this doggone bottom over and over. Now I need to clean up the top. Clean up the top. The 6x squared, he's the only term. -2, -14, that's -16x minus 7. All over. I should just draw arrows, but whatever. Final answer, boom. All right, moving over to number 15. Similar idea, except for we're adding here. So this side is going to be a 3x plus 7, top and bottom. This side is going to be a 4x minus 1, top and bottom. Two big old fractions. So keep these dudes separate. Bam, bam. So on top, I'm going to multiply that out. And I'm going to kind of do this in my head. You can do it off to the side. I know you guys can do it. That's 8x squared minus 2 minus 12. So that's minus 14x plus 3 all over 4x minus 1, 3x plus 7. Add that to, over here, this can be 18x plus 42. I'm not really concerned because this is addition, so no need to worry about distributing crap. We're good to go. Bottoms are the same, so they're going to stay the same. Boom. Tops, we need to gather up some like terms. So I see an 8x squared, chilling. Now I have a -14 and a positive 18. Well, that's a positive 4x. And then the 3 and the 42 hooked me up with a 45. I did try to bottoms up this thing, but it is not factorable. So nothing was going to be able to cancel. We are good to go. Pretty big number, but we got it. All right. Simplify each complex fraction. So this is like a fraction divided by a fraction. So I'm going to keep change flip. Remember, that's my divide by bar. So I really have x minus 6 all over 5 times, flip that. I don't see any way to cancel on the bow tie, so we just got to go straight across. This is 8x minus 48 over 5x plus 10. And then I check, is there a common factor in all three of those numbers, or four of those numbers? Nope. So we are done. This one over here is kind of tough. I don't think this will be on the test. If it is, it'll be a bonus. But I have this thing on top, so I'm just going to kind of call that blue box. So I have this blue box, and it's going to be a fraction. But then I want to keep, so I'm going to keep that. I'm going to change, and I'm going to flip. But I'm going to hold off because that blue box, I got to do something in that box. There's subtraction going on up top there. I need to deal with that. So let's try to kind of sort this out. And let's do x over 4, take away 1 over x. Well, the common denominator is 4x. So to get 4x, I need to multiply this side both by x. And it's the same thing we've been doing up above. To get 4x over here, I got to multiply both these by 4. And so I end up with x squared over 4x minus 4 over 4x, which now I can simplify those into one term. It's just going to be x squared minus 4 all over 4x. Now, you could just start multiplying across here, but I do see a factoring opportunity on this top. So that's just x plus 2, x minus 2. So I just factored that top because I see an opportunity to whittle things down. And I'm going to cancel out this plus 2 and plus 2. So what's left is on top, I'm going to multiply this piece by this piece, which that's x squared minus 4x plus 4 all over 4x. And I don't see a common factor in all 4 of those pieces, so I believe we are good to go. All right, now we're into solving. Now's where the whole game is. Whenever you want to solve, because you see an equal sign, we need to clear all fractions by multiplying by the LCD or LCM, whatever you want to call it, same damn thing. All right, so over here it looks like, the only denominator I have is x. So I need to multiply everybody by x. I need to multiply u by x, u by x, and u by x. So x times x is x squared. Here I get 6x over x, which it cancels. That's why I did it. I wanted to clear out that fraction. Now we have a quadratic to solve. We always set those equal to 0. We factor, or use quadratic formula if we can't. But I think we can. That's an x minus 3, x plus 2. 0 product property. Something times something equals 0. You're 0 at 3. You're 0 at negative 2. Then we have to check those values and try them and see if they work. So I check this 3 and I put it in. Yeah, 6 over 3, that's 2. It's all good. 3 minus 2 is 1. Check the negative 2. Put him in there. 6 over negative 2, well, that's negative 3. A negative 2, take away a negative 3. Yep, that's 1. They both work. No problems. This one has 2 solutions. All right. Next one, over here on the right. I see that I have 4x over x minus 5 and 3x plus 5 over x minus 5. The shortcut is you can basically just come over here and just solve the 2 tops. You can just get rid of the bottoms and just solve the top, because technically all I'm doing is the least common denominator is x minus 5. So if I times this side by x minus 5, and I times this side by x minus 5, all these just cancel, and I'm just left with the top, which just ends up being x equals 5. I circle it, I get all happy. I'm like, I got an answer. But then when I go back and I check this thing, and I try to plug this in, 5 will not work right here, because 5 minus 5 is 0. Can't have 0 on the bottom, or you're going to be undefined. So this technically has no solution. Now, we did find a solution, but when you plug it back in and it doesn't work, it's called extraneous. So that was an extraneous solution. All right? So those happen. All right, getting a little bit rougher here. 3 fractions. I see an x plus 4, I see a 2, and then luckily when I factor this bottom out here, this just ends up being 2 times x plus 4. So it looks like that's going to be my common denominator. So everybody's got to get multiplied by that 2 times x plus 4. And the first one I'll write out the long way. So I'm going to write out 2 times x plus 4. And we're going to multiply that by this first piece. Then we add to that. Now I'm going to multiply a 2 over x plus 4 times the second piece. And then equals. And then this side is already 2x over 2 times x plus 4. But I got to multiply everybody. And what should happen after this step is all the bottoms should disappear. So let's start canceling out. X plus 4, you're gone. So I'm left with the 2x. Over here, the 2 and the 2 are gone. So I'm left with an x squared plus 4x, because I had to multiply that through. Over here, the entire bottom cancels out, and I'm just left with a 2x. If you do not clear out all fractions in the first step, something went wrong. Let's set it equal to 0. When I minus 2x from this side, I just end up with x squared plus 4x, because these dudes end up canceling off. The way I factor this is I yank an x out. Greatest common factor was x. And zero product property, x is either going to be 0 or -4. So I go up top, I do have a slight problem in that when I try this -4, it gives me a 0. So you're not allowed. The only answer here that we can accept is x equals 0. Final answer. All right. Over here on the right, this problem, we get my pen set up. I see there's 3 pieces. Don't let that little 1 kind of hide from you there. You know, there's really a 2 over x times x minus 1 equals, then we just have a 1 there, which is technically this. And then we have a 2 here, which is that. So basically looking at it, I'm going to do this one a tad different just to show you another option. But my LCD is going to be x times x minus 1, because those are the only two terms that we have. So I gotta get rid of every single bottom by multiplying everybody by an x times x minus 1. So I'm just going to put that at the front, x times x minus 1. I'm not going to write it for everybody, so I'm just going to kind of do this with my hand is a little easier, but basically for this first one, everything's going to cancel. You know, this whole piece here and this whole piece here cancel. I'm just left with 2. Over here, I'm going to end up with an x squared minus x, because I had to multiply this by that piece, and then by that piece. Well, when I come over all the way over here to the end, this x minus 1 cancels out with this one, and I'm just going to end up with a 2x. So all the bottoms disappeared. You know, everything canceled here, nothing canceled over the 1. And now we got to clean this up. Set it equal to 0, so I'm going to subtract that 2. I have an x squared, and then the minus x plus x is just, or plus 2x is just plus x. Let's go ahead and figure this out. This is x positive 2, x minus 1. So it looks like -2 and positive 1 are my choices. But we have a big issue. It looks like with this 1, when I put it right there, 1 minus 1 is 0. So you're extraneous. So it looks like my final answer is just going to be x equals -2. All right, we got the last 2. We have inequalities. So the game has changed slightly where we have this inequality here. If you go back to your notes, we put some steps in there. But we're going to end up having a number line. And we should end up having like 3 regions. And we're going to test a point in each region to see if it satisfies the inequality. But how I get the 3 regions are, my first one is, where is it undefined at? What x is it undefined? Well, on the bottom is just 0. So x equals 0 is undefined. So I'm going to put a 0 there. So we know that's not allowed, but it's a boundary. And then my next one is, I'm going to solve this thing just like it had an equal sign. I'm going to ignore that inequality. I'm going to just solve it as if it had an equal sign. So multiply both sides by x. And I'm going to, depending on what way I want to do it, I'll subtract the x. Might look a little more traditional. Divide both sides by -3. So I get -1 1/3, which is over here somewhere. So -4/3 or 1 1/3. And since this doesn't have an equal to bar on it, I want this circle to be open. All right, I want to leave that one open because it cannot be equal. So now I have these 3 boundaries, 3 zones that need to be tested. So I'm going to come in here and I'm going to do some test values. And I got to pick something in each region. So this region will be easy. Let's try 1. So if I put 1 in the original equation, just come up here, slap a 1 in there. Well, that's 5 over 1. And that's greater than -2. So this is a true region. Let's try another point. It looks like, if I try a point in here, maybe I'll try -1. So -1 plus 4 divided by -1. So that's 3 over -1. Well, that's -3. And that's false. -3 is not bigger than -2. So that region does not work. And try the last one. If I go over here, I'll pick something like -2. So -2 plus 4 divided by -2. Well, that ends up being -1. And -1 is bigger. So this is the true region. So I think now I can go ahead and I can state my answer, because this is everything that works. All of this stuff works. So that part is x is greater than 0. All right? But then all of this stuff works. And all of that stuff is x is smaller than -4/3. So x is smaller than -4/3. So it's either the one region or the other region. There's two regions there. So it's an OR problem. So either one of those should satisfy. All right, I'll go a little bit quicker on 23. Just kind of crank this out. So my undefined value, step 1, is x equals 3. So I'm going to put 3 on here. Always open it up. Now we need to step 2. We need to just solve it with an equal sign. So I'll multiply both sides by that x minus 3. I'll get 4x minus 12. Add 12 to both sides. Divide both sides by 4. Well, that's 7/2, or 3.5. So we need to do a 3.5 as well. Again, no equal to bar. So we're going to leave this open. Now it's time to test. So we got these 3 regions here that we need to test each one. So I don't know, let's pick 0, that's easy. So 2 over -3 is -2/3 less than 4, true. Between 3 and 3.5, well, that's a little tricky. I'm going to use 3.25. So I come back up here, and when I put 3.25 in, 3.25 minus 3, well, that's 0.25. 2 divided by 0.25. Well, that's how many quarters go into $2. That's 8. And 8 is not smaller than 4, so you're false. And let's pick a 4 over here. If I slap 4 in there, I get 2 over 1 is less than 4. Yes, 2 is less than 4. So that's true. So now we can come in here. We can kind of figure out our zones. It looks like this stuff works. So x can be greater than 3.5. But then we have a second solution region over here. And that means x is less than 3. All right? So this is your final answer. Now, this is not the answer to the question, so hopefully you are listening to the video and not just watching it. Okay? So I'm going to let me even type on here. Listen. Linda, honey. Listen. So if this region would have worked, let's just say for giggles that region would have worked. Well, how I would express that is I would say, well, x is got to be greater than 3. But at the same time, x is less than 3.5. So that would have been this region. You can write it that way when it's one region because it's an x that's trapped in between two numbers. So just kind of keep those straight. But that was not the case. That was the real answer. Hopefully this helps you get ready for the test part 1. See you.